Well, I saw this integral on YouTube, and I have a much better method to do it. So I would like to share with you. So I let the theta be arctangent cosine over 1 minus sine. But I know that this is just an angle, right? Then my d theta, I take the derivative of both sides, this side with respect to x, so it will be equal to 1 over 1 minus cosine square x over 1 minus sine x, right? Multiply the channel, right? The derivative of this one, which is equal to 1 minus sine square, and the numerator will be negative sine times the denominator, which is 1 over 1 minus sine square, 1 minus sine, minus cosine times the derivative of this one, which is a negative cosine, and then dx. So which means that d theta is equal to this one times this one is 1 minus sine x square minus cosine square x. On the on the numerator would be negative sine x plus sine square plus cosine square on the dx. So which is equal to 1 minus sine x on top. This would be 1 plus sine square x minus 2 sine x minus plus, right? Yeah, the derivative tangent is plus. I'm sorry. So it's a plus cosine square x. Yeah. So this one's dx. Okay. This becomes a 2 1 minus sine x 1 minus sine x dx. So end up with 1/2 dx. So my dx is equal to 2 d theta. Wow, what a result! So my target integral becomes theta times 2 d theta. This is theta. This is 2 theta. Now when x equal to pi, this is negative. Cotangent pi is what? Negative 1, right? This is a 0. So negative 1 is for tangent is a minus quarter pi. When x is equal to 3 pi over 2, for cosine is a 0. So it's 0. So it should end up with theta square. Wow, this is equal to negative pi square over 16. Thank you.